Okay. I am gonna have to check if the streaming thing is working now, because apparently there's all sorts of bugs in OBS, but it's telling me that it's live. So I think we're good. Just gotta make sure I can see myself in the stream, and it says that it's live, so I'm actually not that worried. Okay. But there's always this, yeah, okay, I can see myself. So there's always this awkward bit in the beginning to make sure that the streaming software is working, but I think it is. So good. Hi, everyone. Do let me know where you're dialing in from. I always like to sort of get an impression of folks tuning in, but on that little introduction, today we are talking about ModernBert, which basically got introduced kind of the week before Christmas, like right before the holidays. And it was introduced with this one big blog post. It's basically sort of a new BERT-like model that's a bit more modern. From my perspective, it seems to be a big collaboration with a bunch of people, but the main folks that have been working on it are the folks over at Answer.ai. Jeremy Howard is a person who you might know that's there, but there's also been some collaborations with some folks over at Hugging Face, and there's been this big blog post announcing sort of a quote-unquote new thing. We're going to have a BERT that's a bit more modern. And that's, kind of interesting to me because some of those BERT things that we have is the stream is unlisted. Oh, hang on, let's try to fix that. It's kind of weird to see that happen. It should be public now. There we go. Thanks for the comment. Save. It should be public now. But there's also a paper. And we have, hang on. We seem to have someone joining that is also involved with this. That's kind of nice. Cool. But the main thing that I think is interesting at this point in time is basically what's been released. You have this pre-processing phase for building a BERT model. And the way to kind of think about it is you kind of have this big, good chunk of text. And what you try to do is you try to predict the next word. And to be kind of hand-wavy about it, there's this big attention mechanism, right? Attention, a bunch of words go in. And what we try to get out is the third word. And for lots of different reasons, if you can train a BERT model with an attention mechanism that predicts the next word, and that's the only thing you sort of pre-train it on, then you can make the argument that it does understand a fair few things about language. Like inherently, being able to predict the next word requires some sort of context. And if you turn out to be good at that task, then you might have trained something that's a little bit general for the English language, and then you might also have something that's good for a lot of machine learning purposes. But the thing that's kind of interesting about this point in time, like when they released this is a building block that hasn't really been fine-tuned for anything. So if you want to build a classifier model for this or a proper embedding model, you would typically train something on top of this with a specific data set such that you can fine-tune it towards something. But when this thing came out, it didn't really have anything fine-tuned for it just yet. And what I figured I might do, just kind of a thing that'd be fun, is to see what stuff people have been building on top of this new modern version of BERT, just to get a glimpse of like the zeitgeist. Like, what are people building with this now that it's like super early days? And as we're going to see, I've been doing some benchmarks, not the most serious benchmark, but in the beginning of the week, I had this impression of, there's some new stuff here. ModernBert seems fine, but didn't see anything yet that would change my way of working. And then halfway this week, something did get released that did make me consider, like, oh, wait, I can actually change my way of working now because someone's built something really clever on top of this ModernBert thing. So I'm going to show you some benchmarks that I ran. I'm going to try to discuss the theory a little bit. I'm going to point out a few things that are in this blog post that I think were interesting. And then we're going to dive right into this benchmark that I made inside of Google Colab, and we're going to look at some numbers that I was able to generate. But feel free to ask questions in the meantime. It is also interesting to see, like, yeah, we're gonna maybe look at the paper in a bit as well. But basically, if I were to summarize what ModernBert claims to do, is they made this sort of chart over here. And if you have a look at all of these different sort of pre-existing models, then you've got Roberta, you've got Roberta Base, you've got Roberta Large, you've got dBERTA version 3 Large. And you can kind of see that there's been this Pareto efficient curve, you could say, in terms of number of tokens that you can process per second. And the glue score, which is a benchmark on a bunch of tasks that could be of interest. This is kind of like a public benchmark, you could say. And for the longest time with the standard BERT models, you've kind of had this one efficiency curve where you might get, a higher sort of glue score, but that's not necessarily going to be great for like the amount of time it takes. Like in this axis, higher is worse. But the whole point of ModernBert is that you actually get a bit of a jump that moves the Pareto curve into a different direction. So it's not just the fact that these tools can be seen as more lightweight. It is also the fact that they tend to have better scores. And I think the metaphor that they use in this blog post is that they kind of say it's kind of like a Honda Civic, but the Honda Civic that can race on the racetrack. So it's meant to be a pragmatic thing, but it's definitely something that's got some legs to it. So definitely give this thing a read yourself because it's a pretty good read. But I thought there were like a few things that were just kind of interesting that they did differently. That I like they've got some benchmark numbers and they all look pretty good. But typically, one thing that is always like good to know is like what makes this thing different. Like what's the different than normal BERT? And one thing that I thought was particularly interesting was this idea of more local attention. And let's zoom in on that a bit because I did think this was like a pretty good party trick. Yeah, this image over here. So if you think about the normal attention mechanism in transformers, right? It's basically we've got lots of words sort of going in here, and then this one word in the middle that has attention to all the other words in that sentence or document, and that's going to do some reweighing, and that's where we get our global attention mechanism from. So the thinking here is that a word at the beginning of the sentence can actually still get some influence from a word like 2 sentences later. There's some mingling and mangling, and that's how you can maybe get a good context going. And that's, it's definitely not a bad idea, but you do get this quadratic calculation thing happening where if you have lots and lots and lots of tokens that need to be compared with one another, you do get into this quadratic realm. So there's a fair bit of compute happening there. One of the tricks that seems to work is that you can mix global with local attention. So if you have lots of these global attentions stacked after each other, that's great, but you get a lot of compute that you need. But it turns out that if you mix a little bit of local looking forward with a little bit of global looking forward, and this image also suggests that maybe in the first few attention layers you do global, and you do it again in the final few, but maybe in the middle you don't. That you can actually save a whole bunch of compute without losing a whole lot of accuracy. That seems to be a pattern that's working out. And the more that I started thinking about it, the more that it actually might make sense on an intuitive level as well. Because how often is it the case that something that happens in sentence 1 needs to have all the attention from sentence 6? Like there is also, you want to have some attention that says, hey, let's not forget about stuff that might be far away from each other. But it's also a stretch to claim that you need all of that attention all of the time. Like maybe you can make do with a lot less computation. And what I did think was interesting to see is that this apparently is one of the tricks that they use internally to cause this speed up without losing a whole lot of context, so to say. I thought that was just kind of interesting. And another thing that they seem to do that there's some patching stuff that they are doing as well, which is like sorting the vectors in such a way that the GPUs can more easily process it. I thought that was good too. But the main thing that I thought was also good to point out is that they do a bunch of stuff on the training data. And I can't really find a spot here. But the main thing that they're trying to do is you've got lots of these data sets on Hugging Face now. And you can do your best to sort of train on that. But what they've tried to do as well is just get a diverse set of text data to train on from the beginning. So let's not just train on Wikipedia. Let's maybe train on Wikipedia as well as Stack Overflow, as well as code. And let's try to make sure that the stuff that we train on is diverse in the beginning. And that way, maybe that we also get a little bit more context. And you can read the document. There's basically tricks upon tricks upon tricks. But the two main things that did sort of ring really true to me was that attention mechanism got changed, and they also did a thing with the training data. They seem to have spent a fair amount of time on that. One thing, it's actually here. So the one complaint here is that they say like a lot of these BERT models were trained on Wikipedia and Wikibooks, and there's nothing wrong with those two sources, but it does seem to be a little bit more of a single text modality. And here they really try to do more of a variety, so a little bit more web, a little bit more slang probably because of people typing on the internet. as well as some scientific articles. So the benefit of this is, of course, that if you do everything from Wikipedia and Wikibooks, there's a lot of duplication in that stuff, but they seem to be very mindful of it. One downside of the current approach, which should be pointed out, is that they do focus in on English sources. And I get that you always want to start with English. That's sort of totally fine. But eventually, it would also be nice to get some non-English in there. That's something that they haven't done yet. I can imagine them going in that direction. And non-English is also introducing a couple of hard bits. But yeah, like one should remember that this is all the stuff you're going to do is going to be English first and foremost for the time being. Anyway, there's a couple of people responding now. So Kroom is saying, in my tests, previous models with much extended context length tend to work less well on the shorter. Does anyone have similar experience? This should be fine. Okay, so people are having a discussion, but doesn't seem too particularly relevant to what I've been showing here. So that's just an off-topic thing. That's fine. But anyway, give this a read. This was a good read for the for the Christmas holiday. But what I would like to do now is maybe move a little bit closer towards a bit of a benchmark. So if you want to get this to run at this point in time, you are going to have to install the transformers library from Git. That's a little bit awkward. Like usually you want to just do the pip install, but in this case, I think they probably have a good reason for it. But some of the changes are like so in the in process that they've decided not to make a new release for ModernBert just yet. And they're like that also means that if you want to run all this code, you are going to be forced to install from Git, at least for now a bit. If you want to get the good speed increases, I think you also have to install Triton manually, as well as the Flash Attention library, if I recall correctly. And I'm also installing Seriously over here, because that's the library I use to load in a dataset. And the dataset that I'll be loading in, by the way, is from a hobby project of mine. So I have this archive front page thing, which is basically a GitHub Actions job that runs every day that tries to find me archive articles that I am maybe interested in reading. And the way that it works is I have a sentence classifier. So I get an archive abstract, I split all the different sentences, and then per sentence I classify, is this about a new data set? Because typically articles about new data sets, those are typically interesting to read. So, you know, this is the web app, and you can kind of see like, oh, it's detected a sentence over here that suggests that this might be about a new data set. And I've got lots of pairs of these sentences with a label. So sentence goes in, is it about a new data set? Yes, no. And there's all sorts of little subtleties there. Like I want it to be about a new data set. The data set cannot be about a benchmark. It has to be a data set specifically made for this article. And I've got like 2,500 labels that I've manually annotated myself. And I figured it might be fun to see if I can get some ModernBert stuff to play nice with that data set, with that task in mind. Because there's a little bit of retrieval there. There's also a little bit of classification. So it spans like a little bit more than just classification there. And I figured, okay, let's see if I can make a comparison. And the way that I went about that is I found one, this was the only one I found on Monday when I started doing this work. But on Hugging Face, I did find this one person who trained or who fine-tuned a sort of embedding model for ModernBert. I should immediately stress, this is someone who just spent, I think, an afternoon training for one epoch, and I'm mainly using this because it has a nice integration with sentence transformers, the library, so it meant that I didn't have to do much. So it's it's a transformer and then kind of like a pooling layer. So you know, it's you can probably come up with a better embedding model, is what I want to say here. But this was the thing that was available to me, so I figured let's see if I can play around with this, and let's compare this to other sentence transformer models just to get an impression to see if we can if we have something that's a bit more powerful, so to say. Or at least different. Like that's the thing I was interested in. Can I see something that's just a little bit different? Now, the way that this all, of course, all works is you can load the sentence transformer library as you would normally. You can give it a couple of sentences. You call your sentence transformer model. You give it this string. It automatically downloads the whole thing. You give it your sentences, and out come these embeddings, and they have a certain shape. But basically, for every single sentence that I have over here, so I've got 3 sentences, 1, 2, and 3 sentences. What comes out over here also has a specific dimension. So for each document that goes in, there's like 768 numbers that are attached. And those are things that you can use for lots of different tasks, typically machine learning or retrieval. But you can also get like similarity scores out. There's all sorts of stuff that you can do. So, okay, that'll be my ModernBert thing. That'll be one of the things that I'll be comparing against. And I'm going to use a trackpad, actually, because it's a little bit more comfortable than this dial over here. Here you can see me download my, my JSON-L file that has all of my labels. And then I figured, okay, given that I have got these embeddings, like, let's build a couple of scikit-learn components that can just do something with that embedding that kind of gets close to a classification, but definitely uses the embedding as much as it can. And I kind of came up with like 3 ways to kind of explore that. I've got this thing called the zero-shot classifier. The way it works is you give it your transformer model, and then you also give it a positive example as well as a negative example. So this is just text, right? So you're just saying, I've got this one bit of text that is very much like a positive class that I'm interested in. I've got this other text that's very much like a negative class that I'm interested in. And then what I can do when the new text comes in, I can calculate the distance of the embedding of the new text to the distance, like to the positive embedding and to the negative one. And that distance can be interpreted as a proba value, kind of, and you can normalize it. That can be a way to get a classification going. So this, what I call quote unquote, we're going to see in a bit that this doesn't work so well, but this quote unquote scikit-learn zero-shot technique is you can kind of say, this is what I am interested in, this is what I'm not interested in. Given that, make all the predictions that you want. And the hope is that the embedding model under the hood is going to facilitate the knowledge that I need in order to make a good classification. You can kind of go in that direction. I figured, what else can I do? Well, another thing you could also do is you could say, well, let's not go for like a positive label that I need and a negative one. Let's instead just say, oh, I'll just come up with like this one positive thing that I'm interested in detecting. The way to maybe think about that is that I have this, let's say I've got this origin 0, and then I've got this high dimensional vector that points to the embedding of my positive label, so to say. Like that's sort of a way to think about it. But what you could do is you could say, well, whatever new text kind of comes in. So this is like, let's say some sort of new text. But there is some sort of a distance between the new text and the positive one. And what I can do during training is I can just say, look, let's just look at all the examples that I have got in my training set, and let's just figure out some sort of a threshold, where if you're over the threshold, then I'm going to assume it's a positive label. And if you're under the threshold with your new text, you're going to be sort of negative. And it's kind of a very similar trick to what I had before. It's just that by doing this, you're actually reusing the labels a bit more. Instead of having just one negative label and one positive label and hoping for the best, you actually have lots and lots of data to figure out what the good threshold value should be over here. So that's like a different way of reusing some sort of a modern BERT embedding, so to say, to see if you can do something clever with it. And then finally, I figured, what's the most straightforward thing that you could possibly do? And then I figured, what you can also just... yeah, shortcuts. Another thing that you can also go ahead and do is you can also just say, look, I've got text that goes in on one end, that goes into some sort of a embedding thing, and lo and behold, when I get something out over here, I've got some sort of X, some sort of representation. I can give my dense stuff as well as some labels to a logistic regression, and this can also make lots of predictions on my behalf. This is kind of like a normal scikit-learn pipeline in a way. But these are like 3 different ways to sort of reuse these ModernBert embeddings. And what I can do is I can compare those embeddings with embeddings that already exist in sentence transformers. And I can kind of just see, like, if I were doing this on like an actual use case, kind of, because that's the whole reason why I have this data set, like, what would the results just be? So let's go over a few things. So let's get started with just the embedded regressed classifier. So that's the thing I just explained first. So we're just going to embed stuff, and then we're going to train logistic regression, and that's about it. Oh, and there's some people saying that it's already merged in main. We're just waiting for the next release of transformers to be upstream. Yeah, okay, so that makes sense. I can imagine that, as alluded to earlier, you have to install from Git right now. I can imagine that Transformers just likes to have a release schedule, which means that there's like a date they have in mind to make the new release of Transformers. It felt like a temporary thing anyway. I just want to make sure that if you just do pip install Transformers, this doesn't work. So right now you are going to have to install from the GitHub repo. But I'm sure it's going to, like, I'm sure they're gonna release a new version of Transformers with the stuff in it at some point. Like I don't know when, but it's gonna be soonish, I think. But yeah, all right, keep on pressing the wrong button there. But yeah, back to ModernBert. Like a thing that you could do in this case, what I'm doing here is I'm saying, look, there's just a bunch of models. All of these models have different embeddings attached to them, and I've got this thing that Joe32140 made, but there's also this Nomic AI group that made some embeddings, and Nomic does some interesting work. So a few things that I'm tracking, like the first number, like the first thing that you're going to see here is just which model have I used. That's followed by what's the accuracy that I see when I cross-validate, followed by how much time does it take to actually do the inference. And I'm doing all of this, by the way, on a TPU. That's when I ran this on the TPU inside of Google Colab. Someone is pointing out, which is correct, that some of these models might actually benefit from having some sort of a passage, which I'm not passing along. So you should do something like, hey, this is a document and this is a query. I think some of those models actually do that. But I guess the main point that I want to highlight, at least for now, is that roughly on this one data set, I get about 86 is the minimum, all the way up until kind of 88 over here. That's like the sort of the ballpark in terms of like classification accuracy on this one task. So the whole point here is not so much to suggest that this is the state-of-the-art thing, but the whole point is that if you just go for a very basic classifier on a, I think, data set that's relatively easy, you do seem to be getting into this sort of ballpark that's relatively the same. So it could be the case that if you decide to model stuff this way, ModernBert is not necessarily going to be the biggest game changer just yet. Again, I should stress, this is a relatively easy data set, I think. These are just sentences. These aren't like big paragraphs or anything like that. But like when you're benchmarking, like it's also good to just make this comparison, just so you can have some numbers to compare against. Another thing I also noticed is that compared to these relatively lightweight models that you have in sentence transformers, and I think it's also safe to say these do have like shorter context windows, I think. Could be wrong with that, but that is my impression. You do notice that these are just a little bit quicker than some of these over here. So, okay, I thought that was just kind of an interesting data point, right? Like, even though ModernBert's around and there's stuff to like about it, it's not necessarily the case that the old ways of working are necessarily worse immediately. That's like just an observation. But one thing that I do want to maybe just stress right now, right? Like, a thing that's already super duper useful is the fact that you do have embedding models that are just slightly different. So a trick that I figured I would do just at this point in time, like you see that they're kind of all in the same ballpark. But I was kind of wondering, do these models disagree with one another? Because that'd be interesting too. Like, I would argue that because these embeddings are all just slightly different, it would be kind of normal if they also disagree sometimes, right? Even though these accuracy numbers are all just kind of the same. So I also made this kind of a disagreement matrix, if you will. So I've got this dictionary with all sorts of predictions in it, and I'm just calculating the Manhattan distance from all the predictions that are being made by these 5 models. And you can kind of see that some models actually agree a bit more and some models actually disagree a bit more. In particular, one thing I thought was just kind of interesting is that a lot of these models seem to disagree with what this BERT model's doing. Like the 4th model over here, that's where you see these big numbers kind of pop up. So that's, I guess, a little bit interesting. It also makes sense because I think this was only trained for like 1 epoch. But the reason that I bring this up is not so much like, oh, those numbers specifically are just super interesting. The reason I bring this up is because this is a great moment in time to check your labels. Because when 2 models that are performing pretty well disagree with one another, that's a really great time to just check the label to see what's happening there. And I actually found bad labels in my data set by doing this. So I'm just comparing the results from this lightweight int-float model compared to the all MP base v2 model. If I really felt like it, I could definitely look at all of these examples, and like makes a lot of sense. Like when there's data points where lots of models disagree, right? That's also a good point in time to have a look. But the main thing I figured I would look at is like, when does this data set have a negative label, and while the models disagree. And I have just found a lot of sentences where it's pretty clear that it might actually be about a new data set that just has the bad label attached to it. So right here, the data set and source code will be released on GitHub soon. Yeah, if I read that sentence, I can kind of imagine that it's about a new data set. Kind of like, it feels plausible at least. Oh, why is there a negative label? Oh, that's actually kind of bad. So, like, just to keep in the back of your mind, like, one thing I would argue that's already kind of cool about having ModernBert around, if nothing else, is the fact that you can always do this trick. You are, especially if you're doing English, like, you will have a BERT model that's just trained on slightly different data. So if you're going to do any kind of lightweight fine tuning on top of that, it is going to give you something that is different from existing BERT models. That on its own, for data quality reasons, is super duper useful. Like, that's, I think, a thing to celebrate also a little bit here. It's a trick that I've been using all across my career. Like when two models disagree, something interesting might be happening. And when you have new embedding models, especially when you have like a new parent model, that's like a really great use case that would be kind of a shame not to sort of zoom in on. And it was just so easy to find some bad labels by doing this. So another reason that I want to mention that is it also allows me to put like a grain of salt on these numbers. Like these are pretty okay accuracy numbers, but let's imagine maybe that 5% to 10% of all the labels in this data set maybe have a bad label attached. That's also like a reality we have to imagine when we look at the... this is, I think, the first win that I do want to claim for ModernBert. Even if you don't get necessarily better accuracy numbers from models right away, like you would hope so maybe, but like even if it doesn't, just the fact that you could go ahead and reuse it for label quality reasons, that's a win. And I would have to do like a proper benchmark to see if I can find lots of bad labels across many different data sets, but I am willing to put some money in it that the fact that this model is pretty darn accurate, or sorry, this model is still pretty darn accurate when I compare it to the other models. But the fact that there's so much disagreement with all the other models, that is interesting to me, at least. Something that at least should not be ignored. So, with that little positive rant out of the way that I'm pretty excited about, I don't see any new relevant questions come in, so I'm going to move on to the next thing I wanted to talk about. So I did this, I showed you the results for this classifier. That's just a logistic regression at the end. Let's now compare it to another classifier. This is the one that works on the threshold. So a bit of a caveat on that one. The way that this works is I am giving it like one and only one positive label to base everything on. Like I'm doing the threshold thing where I go through my entire data set to figure out a good threshold with distance, but I'm still giving it like one and only one example as a positive class. So that's kind of zero shot like, but it's also like playing with fire a little bit because you do have to come up with a really good example that can summarize everything in your data set. So I figured I would give it the sentence, this article introduces a new data set for a specific use case. And then, I'm definitely still doing thresholding, and that's all something I'm learning from the data. So I'm definitely learning something from the data set. But at the same time, it also kind of feels like I'm not giving it too much because it does require me to use like my own knowledge of English to come up with a good label. And what I just noticed here is that it's kind of the same story as before. Like I didn't see that different accuracy numbers appear. This is all kind of in the 86, 87 ballpark range. And the training times are also like relatively the same. The main bulk of the time that's being spent here is on doing the embeddings. Note, by the way, that I'm doing, like the implementation here is a little bit silly. If you were to do this for realsies, you should cache the embeddings. Like I'm recalculating them now. That makes no sense, probably. But okay, like one thing I did find interesting is that it's not like I get very different numbers here, so that's kind of fine too, I guess. But then I figured what might happen if I do the positive and negative thing. And it was kind of the little bit more exciting thing because this is a little bit more retrieval-like. The thing that you insert as the positive and negative label, you're really not learning anything from the data set. Like the two things you pass in that really defines the prediction quality, so to say. So we're going to move towards that zero shot. No, it's not really zero shot, but like zero shot like classifier at this point. And once again, I've got this one thing from ModernBert, and I'm comparing it to all the other models from sentence transformers. Suddenly, when you're going down this route, the results are just much, much worse. And it also kind of makes sense. So the negative label is the article introduced me a new benchmark, and the positive label is this article introduces a new data set. Okay, super cool, but there's way more nuance in my data set than just these two examples. There's lots of sort of stuff in between where the labels themselves are doing a pretty good job of defining what is interesting and what isn't. So it's not that big of a surprise that, these models end up performing a lot worse. The one thing I did find somewhat surprising is that It is just so much worse, first of all. And second of all, this is binary classification. So if you get a 26% accuracy score, that means if you were just doing the opposite of what the model was doing, you would get a pretty good model. And that is something I just wouldn't have expected, really. So in this particular case, my impression is that those two embeddings are just barely enough of a difference to really indicate what you're interested in. And I can also imagine, right, like if I were the embedding model, there's one token that's different in both of these two embeddings. And both of these two sentences are about introducing something new. So, like, if I think about the direction of both of those vectors, I would actually kind of imagine them to be quite similar to start with. And if I were to kind of like imagine, okay, suppose I've got these two vectors that are just kind of similar, right? And then there's going to be some sort of a splitting line between them over here. Like, okay, is this going to be a good separating boundary, but just based off of two vectors that are inherently similar anyway? So thinking about it that way, it wasn't that much of a surprise to see super small numbers over here. Although I was kind of surprised to see them being this disastrously small. It suggests to me that the two vectors for positive and negative are just too similar. So I think I'm trying to combat that in the next example, where I'm saying I've got this one article that introduces a new data set, and the negative example is this data set is old, or it is part of a benchmark, or it is not public. So I'm really just trying to emphasize, like, what properties do I not want to have about that data set, and seeing if that maybe captures something. And that's actually kind of interesting, because I do see that ModernBert is actually able to pick up a little bit of slack there. Although I should say that this infloat E5 small model, I could be wrong, but I think this is fine-tuned on retrieval. This one seems to outperform it a bit. Again, I don't want to look too much into this example because it's a little bit silly, but you do start noticing that ModernBert at least is also doing some retrieval-ish things here a little bit better than before, so that's, I think, positive. And I've tried this other example where I say there is no new public data set, and when I tried that, ModernBert definitely was the best one out of all of them. But I think, again, when I do stuff like this, I don't know how good of a benchmark this is, because I am really basing all of this off of two examples, and it's kind of like pretending that a retrieval task is a classification task. So I was doing this, and I was kind of thinking, like, all right, so my benchmark, I've got some numbers, and I can see some of the stuff that ModernBert here is doing that I think it was, kind of nice. But one thing I figured I should do maybe at this point in time was, okay, I'm doing everything with embedding models now. Maybe I shouldn't fool myself. Like, maybe I should also train just a very simple count vectorizer, logistic regression model, bag of words model, basically. Like, maybe I should just compare with that, right? So that's what I'm doing here. I'm saying I've got a count vectorizer, I've got logistic regression, and what do I just get if I just do basic count vectorizer with logistic regression? And let's also do TF-IDF. I want to do that, just the TF-IDF model, 0.88%. This is the best performing model out of everything I've just shown you. And if I look at the amount of time it takes to train and predict, it's also like easily the quickest by a good margin. So maybe what I've been doing here is I've been actually taking a data set that, still has some label errors in it, but maybe this classification data set is just too easy for this benchmark in a way. Like, when would you introduce embedding models in your classification pipeline? Well, maybe when bag of words just doesn't cut it. And that could be examples where, it's very context heavy, or there's like subtlety involved, and like those sorts of situations. But if you can do it with bag of words, like, why are we even bothering with embedding models? And this was the state I was in on Monday. Like, that was kind of the feeling. Like, okay, I've ran some benchmarks, I'm looking at the basic thing that I've tried. This is also, by the way, like a very Vincent thing to sort of conclude, right? Like, oh, dang, so the linear model also just kind of works. Why am I not doing that? But then on Monday evening, I saw a tweet, or like a Blue Sky message, or whatever. I think it was LinkedIn even. But it was basically Tom from Hugging Face, the maintainer of the sentence transformers library. He actually noticed a new fine-tuned model on ModernBert that does zero-shot classification proper. So there's this user called, I think I hope I pronounced the name correctly, but Moritz Lauger. Moritz had the BERT V3 zero-shot model that was already there. That was before ModernBert. And what I can do is the way that it works, and that's the reason why I'm showing it here, is this is a specific pipeline inside of Hugging Face. And what that allows you to do is it allows you to just define, these are the classes that I'm interested in. There's a little bit of a formality that you have to define your classes, and you should also come up with a hypothesis template. But basically, you can have your text and your labels as inputs to the system, and then it will just do the classification on the spot. No need for specific training towards those labels. That's the whole point of the zero-shot pipeline. And there's tons of tricks internally, and I'm doing a bit of a hand-wavy thing. But you can see over here that once you've defined your zero-shot classifier by loading this model that BERT's made, and this one is trained on top of the BERT, then you can see that I can give it a text, I can give it some classes, and then it's able to give me this output where this is the sentence that's kind of going in, these are the labels, and then for each and every label, there's like a chance that it belongs to it. And in this particular case, is a sentence about Angela Merkel, who's a politician, so yes, this is about politics. So far so good. Like, we've had these pre-existing zero-shot classification models before already, but now the tweet that I read said that this person also trained one for ModernBert. And then I figured let's maybe benchmark that, actually. Let's compare that to the scikit-learn models that I've got and the stuff that I've been trying to do on top of embedding models. And okay, if I take the BERT thing, which was the thing that existed before ModernBert, if I take that, then it takes about like a minute and 50 seconds or so to go through all of my texts that I have. And this is on a GPU. And then I get a model that's like 899, like 89.9% accurate, which actually outperforms my logistic regression, albeit by a non-statistically super valid margin. But okay, I get something that actually outperformed my 2000 labels thing. So that was interesting. But then, of course, we also had this new model trained on top of ModernBert. So same zero-shot pipeline idea, but instead of having the BERT, like the heavyweight thing, be the underlying pre-training model, you can also do a thing with ModernBert. And the same person retrained the system on that. Everything works the exact same way. The numbers seem about the same. But the thing that's of interest here is that I pretty much get the same performance in terms of accuracy. Like, this is same ballpark basically, but it's a good chunk quicker. Like, that's the thing that I thought was interesting here. This was like almost 2 minutes, and this is closer to 1 minute. It's not twice as fast just quite yet. But one thing that did make me realize is like, hey, hang on, actually, I'm not sure if this is a fair comparison now that I look at it real quick, because I seem to have a model here. This is ModernBert large, zero-shot. And I'm comparing it to base zero-shot down below here. So I might need to rerun this on because I think I'm taking the BERT large over here. So okay, so the comparison might not be the fairest, actually. I should double check that. And maybe I have time in a bit to rerun the script. But the one thing I would want to say, though, is that... oh, wait, actually, no, never mind. Yeah, so this is ModernBert large. Sorry, ModernBert large is 1 minute 17 seconds. I was scrolling too quick. And below, I've got ModernBert base. That's the most accurate one on everything so far, and that takes a minute. So that's like almost twice as fast. So that's yeah, okay. So the conclusion I had in my mind still makes sense. Sorry for the rambling. This ModernBert base zero-shot version 2 that was trained by Moritz, that is a good chunk quicker than the original BERT zero-shot one. And this is kind of the first time that's happened to me. I seem to have stumbled upon something that might give me a little bit of pause in terms of like the way that I work. Like, I still think labeling your own data is good for understanding your own data set, but okay, you get like 2,500 classifications within a minute on a TPU on Google Colab with 90% accuracy on something that's kind of zero-shot. That's kind of nice. Like, hang on, like I still think it's good to have my other embedding models and my bag of words model, and we should check when they disagree. Like, all that stuff is good, but hang on. Within a month, I think, I have something that's been fine-tuned on top of ModernBert that I can add to my tool belt, and that is actually an amazing win. Usually, it happens a bit slower, is what I'll say. Like, if I think about when the first Hugging Face model came out, and when the first sort of fine-tuned models came out that were useful to my pipeline, that actually took a good year. But there's been a good community effort already on top of this ModernBert stuff. And we should remember, this is only English. There's a lot of non-English stuff that also needs to happen. In this particular data set, I am doing stuff with archive articles, and it's likely that ModernBert had a little bit of that in its training data, so there's a little bit of tailwind that I'm achieving there. But I will say this is the cool bit about checking out ModernBert at this point in time. People are just starting out, like fine-tuning stuff on top of this, and that's just kind of fun, nice, and exciting. So another thing that might also be fun to mention, I was talking to yeah, I can kind of talk about that. So next week, like, there's a podcast that'll be released next week, and I've been talking to someone that might want to like get some highly distilled word embeddings out of these ModernBert models. If you've been watching the live stream, you might be able to guess who's going to be the guest. But there's like some other like extreme distillation stuff you might be able to do on this as well. People are probably going to figure out nice ways to get fast word embeddings for mobile devices. There's there's lots of different tasks that people are fine tuning this stuff on right now. And that's and like I did not expect, like, at the beginning of the week I was kind of just playing around with this and kind of going like, all right, it's kind of fun to play with, and I'm sure people will find out useful stuff. And within the same week it went to, oh, there is a useful thing that someone just fine-tuned. And like it does seem that this is a quite approachable, fine-tunable, you only need one GPU and a good data set to get some results going. So like, I don't know, like, that was just kind of the fun exercise I did this week. I just figured I should explore this. And I ended up stumbling upon something that actually turned out to be quite useful. That was kind of the exciting thing that happened this week. I still think it's safe to say that it's very much early days. Like, there's still a whole lot of fine tuning that hasn't happened yet that probably should happen soonish. But I will also just say, like, it's the lightweight models that I've got over here, like. This takes, yeah, so like bag of words takes like half a second to do everything compared to a full minute using a TPU, right? So there's still like a little bit of a difference. But a full minute for like a few thousand examples, you are getting into the pragmatic. Honda Civic might be able to go onto a racetrack domain. And the fact that I was able to sort of get a taste of that within this first week, I thought was just a great way to start the year. So yeah, that's the main thing I kind of just wanted to show. I did not expect this, but it yeah, this is fun and good stuff. I really hope they do stuff for non-English too. That's the one thing I do want to repeat, because English is just one language. But yeah, there's a couple of people talking about some of the stuff I said. So let's see if I could. Yeah, so people all are comparing some embedding models that I've not tried yet. People agree that model disagreement is a good thing. If you're working, it is working on NLI. Yeah, so task source ModernBert base NLI is another model that's been out. That's a comment from Antoine. Let's just throw that into Google and see what comes out. Task source ModernBert. I forget what do people remember what NLI stands for? I think it's a natural language inference or something. It feels like it's a bunch of different tasks. But yeah, it feels like this is some classification might be in here. But you see a couple of glue scores, and these numbers are sort of high, and 1,000 downloads. This is probably, yeah, also a zero-shot classifier. There you go. Yeah, so it could also be a very good choice. Not familiar with natural language interface. Yeah, there you go. Task source is also a little bit more of an organization instead of a single user. It seems like I'm not too familiar with this, but you're gonna get a zoo, I think, of these models being trained on the short term. And I guess like one thing might be good to show as well, because we do seem to have, and I hope Antoine. Because I think there we go. There's also because I haven't read this yet. I've glanced at it, but there is also like a proper research paper if you're interested in learning more about the ModernBert stack. Yeah, so NVIDIA, Hugging Face, John Hopkins, a bunch of people. It is my impression that there's this group called Light On. I believe that they also submit a lot of compute resources for this work. But if you're interested in sort of, I would still recommend starting with the blog post maybe first. But if you're interested in reading the proper academic article, that's also something that is in here. And one thing that is also kind of nice to show is if you go to the acknowledgement section, there's definitely a kind of a group effort feeling in all of this as well. So it feels like something a lot of people are getting behind. So if you're interested in playing around with some embedding things, I would recommend giving this ModernBert thing a try. One extra thing that I do want to maybe mention, by the way, that's kind of in this domain, is I have this library called Embedder. The way that this library is designed is if you want to have scikit-learn pipelines that use some of these embedding models, you do get scikit-learn components just for exactly that. So if you want to use Embedder, that's been a library that's been out for a while, and once the new transformer model is like pushed to PyPI main instead of GitHub, you should be able to use it right out of the box. But one thing I just want to mention as well is that Scrub GitHub, there we go, which is basically this bigger preparation library thing. This is not my personal project. This is like a proper project, I would argue. Like multiple colleagues of mine work on this. The whole point here is a little bit like, can we do proper data cleaning for tabular data? But they've also started noticing that maybe some embedding models will be good. So if you go to the API section, you can see this big fancy new, can I scroll down here? I think it was a text encoder. There we go, text encoder. The text encoder works a little bit differently than what we do inside of Embedder, but there are reasons for doing it this way. But one thing to note is that if you are a Scrub user, you also have access to some of these embedding models now. The way that this works is a little bit different. I just want to maybe paraphrase that. Like one assumption for Scrub is that most people are probably going to be interested in using some sort of a gradient boosted ensemble model. That also, like those models prefer if the data is not too wide. So 700 embedding dimensionality thing is not the way to go forward. So the way that this text encoder currently works is that they do a PCA pass after the embedding. And that's like the number of components. If you don't want that, you have to set that to none. But there is a PCA that happens afterwards. That's the thing to be mindful of. My Embedder library doesn't do that because my library assumes that you're using a linear model afterwards. But that is a somewhat fair consideration here. There's also, so like if you go to the GitHub page, there's like some academic articles that talk about the reasoning and all that. But yeah, you can start thinking about using some of these embedding models just a bit more for scikit-learn pipelines as well. It's not just crazy old Vincent with his linear model trick doing Embedder stuff. Like proper scikit-learn maintainers have also kind of gotten on board. And they are also very eager to get some feedback. So if you find yourself interested in trying out some of these embedding models and you want to do that in scikit-learn pipelines, I will argue that this text encoder thing is something to consider as well. Feel free to use my own library, but it's not a bad idea to also consider libraries that are maintained by more than one person. We got some extra feedback from folks. Yeah, so natural language, yeah, exactly. So basically we were talking about this is also a zero-shot model, but there was just a little bit of extra context. Like some of these tasks are about like, hey, is it there's two texts coming in, is this a contradiction? Or hey, there's some text coming in, what is the is this a neutral thing? I wouldn't be surprised there's sentiment in here as well, but yeah, the entailment, there you go. But it's like lots of different data sets that they're benchmarking on. Basically this it's an interesting time because like finding a good benchmark is still kind of a hard thing. It's very easy to I mean, you get some people that probably game the benchmarks. I'm not suggesting that these people have done it, but like finding a good benchmark is still kind of a hard thing. And like that's also kind of a lesson I learned here. Like I'm still super happy that I'm super happy I found the zero-shot thing, but I'm also still super happy that I at least did the exercise of also doing this logistic regression trick. I do want to maybe say like one thing about this regression thing though, like logistic regression and bag of words things, they tend to work quite well for English, and they also tend to work quite well for languages that are a little bit like English. But there are lots of languages out there where this trick might not work as well. I'm hoping I'm not getting it too wrong, but I think one language that comes to mind is Norwegian. So in Dutch, right? If you have like a little rabbit, that's the English thing. But if you were speaking Dutch, like rabbit in Dutch would be konijn. But instead of saying little rabbit, the Dutch basically add a little suffix to the word. So we say konijntje. This ch at the end makes it clear that the rabbit is indeed a small rabbit. And we do it with lots of different words. We don't do it in an extreme sense. Like there are also languages, and I think Norwegian was one of them. Don't pin me on this one, but I think on the house, right? So if you want to say like the chimney is on the house, then like in English you would just have separate words for it. But I believe the Norwegian way of saying it would be house on or something like that. You can sometimes also get these kinds of words as suffixes or prefixes depending on what you're doing. And this is also why in Norwegian you can get crazy long words. Now, bag of words is going to crumble a little bit there, of course, because suddenly there's lots of these morphological deviations that you can have from a base form. And English doesn't do that a whole lot. So that's why bag of words tends to work quite well for English. If you're ever going to go try and do Norwegian for like bag of words stuff, like one thing I would really emphasize is that you do want to maybe set the analyzer to be based on the character with a word boundary. Because then you're going to get like a sliding window of characters to represent the different tokens. And you probably want to, I think it was like an n-gram setting. I forget the one, but you want to maybe do something like 2 to 4, or maybe a bit longer. Like you're going to want to do tricks like this in order to make a fair comparison, but you are also going to get like a vocabulary that just basically explodes if you're going to go down this route. So just be aware that you can go down that route. It's just that, again, this bag of words thing, it doesn't work as well for every language out there. And I also like to think that one of the reasons why English is typically also an easy language for a lot of these sort of sentiment tasks or classification tasks also kind of has to do with that phenomenon. Like morphologically speaking, English is not the most complex language out there, but there are lots of non-English languages out there that sort of become a bit harder when you do this. And I'm not even talking about like Unicode shenanigans, which is also a thing that can bite you sometimes. Yeah, and then people are commenting that Slavic languages also have a couple of these phenomenons in it. I'm like, I've worked at companies like Explosion before, and before that at Raza. Like, I'm not a linguist, but I was surrounded by linguists at some point. Like, they were part of my team, and enough of sort of their linguistic attitude has radiated on me such that I can claim that if you're going to do NLP, it helps to be kind of specific. Like doing NLP for English is totally different than doing NLP for other languages at times. But yeah, there you go. This is a very brief and very opinionated glimpse of what I think is interesting about ModernBert. Please don't replace everything with it just yet, but it is very cool to just get this snapshot in time where this is like a sort of proliferation of people's sort of retraining systems again on top of this new BERT stack. I thought that was just kind of cool. I think if people have questions, by the way, now would be a great time to ask, because like we actually have like one of the authors tuning in, someone who's actually collaborated on this paper over here. So that would be like, feel free to ask questions, maybe not to me, but to Antoine. Like he feels like he's more of an authority on this than I am. But my 2 cents, like it's not so much. The exciting thing here isn't so much what ModernBert is right now, but the more exciting thing is that that people are sort of excited about sort of training new stuff on this stack. Like that's the main thing that feels exciting. So yeah, I'm just gonna wait for a few moments just to see if there's any other questions. But if not, I'm also completely aware of the fact that and Antoine is saying thanks for hosting the paper. Thanks for doing the work, Antoine. Like the thank you should go in the other direction. Now, and also this is all open source stuff, right? So this is cool beans. I would say like I'm looking forward to sort of playing around with some embedding some more. That's definitely something that's happening here. But yeah, any questions for me, I suppose, or to Antoine at this point in time? People can also take questions offline. Like people have profiles on GitHub and social media these days. So I'm sure you can find each other. But I will also share. Yeah. So the thing is, can I share this link actually? Share the notebook. Copy link. anyone with the link, copy link. And I have just added the link in the chat, and I have also just, I'm going to get Colab link is now also added in the show note description. There you go. Yes. Another thing, feel free to do your own benchmarks though. Like this is just a benchmark on kind of a silly data set that I've been maintaining that has lots of label errors in it. Feel free to maybe, like it's, I would love it if people are inspired by the way of working a little bit more than the results that I'm sharing per se, because it's just a single data set, like with just a couple of thousand of labels. But what I am hoping is that people sort of feel empowered to maybe give this a spin. And especially if, yeah, because that's a thing I'm hoping more people might consider. There are a lot of these tabular data sets out there that do have a text column in them. So you can definitely imagine if you're doing some sort of bot detection, then sure, like some stuff that matters is the time the bot was active, like how many sessions does the bot have or the user, etc. But what the bot is saying might also be something that's useful. And yeah, for that, you're still kind of in this tabular data domain, but you're also in NLP domain. So for that kind of stuff, I would love it if people give us more feedback on maybe this text encoder, or if you use MBetter. Again, I do think please give this text encoder a spin, because that gets a little bit more serious attention. But I do think there's a good story for these embedding models for tabular data as well. There's a couple of these moments in time when, for sure, we are dealing with text inside of tabular data. And access to these embedding models is becoming kind of a standard now, especially in Scrub. One other thing to also remember is that this sort of technique is also kind of useful for data deduplication, and there's some support in Scrub for that as well. So yeah, definitely keep all that good stuff in mind. Final time to ask me questions. You can also ask me questions if you go to our Discord, discord.probable.ai. You can ask me anything, and we share some content stuff as well. A final thing that I think might also just be good to talk about, if you look for Sample Space, the podcast, and especially if you go to rss.com, if you add that, yeah, so rss.com, that has the Sample Space podcast listed. This is the podcast that we host. A new episode is going out on Wednesday if you follow us on your podcast player. And if you're on YouTube, you are going to be able to follow us on YouTube as well. But I'm going to be interviewing someone who's making very, very lightweight embeddings. We're going to talk about aggressive exclamation point distillation techniques on that one. So if you liked what you saw here, you're probably also going to like to see what we're talking about in that podcast. I'm very happy to have that one out there. Oh, right. So someone is asking about Matrushka embeddings versus PCA. I mean, the main thing I think Matrushka embeddings should work out of the box, if I'm not mistaken. It's just you need a different string for the name of the model. I don't know if... I mean, yeah, so you might suffer like a little bit of a computational hit if you use the text encoder, because you are training like a separate PCA thing afterwards, right? But you should be able to use your Matrushka models on your own task already. And the main thing to remember is just benchmark it and figure out if it works. I have tried out Matrushka embeddings in a live stream like a couple months ago, and I was able to sort of measure that Matrushka embeddings did have some things going for it, but only on specific data sets, if I recall correctly. And like the main thing I would argue, like if you are interested in, let's go to the docs one more time, text encoder. Like if you are going to be using this text encoder, this number of components thing is probably the main thing I would try to benchmark. Because going from like 700 dimensions down to 30 can, you can lose quite a bit of information there. So I might try like 100 first or something like that. And this is independent on whether or not you're using a normal sentence transformer thing or a Matrushka thing. Like mileage can vary across data sets and tasks as well. So just make sure you benchmark it and keep in mind that number of components thing. That's the main advice I would have. And someone is asking, supports Matrushka. Yeah, so the ModernBert embed base does support the Matrushka learning, I think. You need you have to train specifically for it. I think people are still waiting to do that. Oh, and apparently Antoine is suggesting that new models will be released next week. So that's stuff to look forward to. Yeah, people are just going to want to have fine tune on your own data sets. That's the main advice I would have here. But there is new stuff coming out, and I am looking forward to more lightweight Honda Civics being able to drive on the racetrack, and not everyone needing to have a Ferrari. Because not everyone has access to 20 GPUs. So if we can do in my mind, it'd be nice if we didn't even need to have a GPU. But if we have one GPU, we should also be able to do a lot of interesting stuff. But yeah, it's time for lunch. I need to get food. So hopefully people enjoyed this. Ask me anything on the if you have questions about the content, I would prefer that to go into the Discord, because then we can have nice threads and sort of have a little group huddle going. So definitely join our Discord if you haven't already. But yeah, ModernBert. Let's have a Honda Civic on the racetrack. Have a good one, folks.